Hey, you guys. So we're going to take some notes today. So have a clean sheet of paper. Go ahead and put today's date on it. It is Wednesday, October the 21st. And we're going to title it Forces and Motion. Okay. So what is motion? Motion is a change in position. So um, here's a position. If I change it, it's not here anymore. It's, that's a change in motion. It's a change in position. It moved. Um, Anything that goes from one position to another, that's motion. A change in motion is caused by a force. Using muscles, not strong muscles. I move my finger. Okay, so that was a force from within. But a change in motion is caused by a force, whether it's a push or a pull on an object caused by an interaction of objects by contact, which is a contact force, meaning it touches, or it's from a distance. A force is a push or pull on an object caused by an interaction of objects. We've gone over this, either by contact or by distance. Forces are measured in newtons. That is the unit of measure, newtons, and we use a capital N. Measured with a spring scale, and forces act in pairs. They act in pairs. So these are some different types of forces. We have gravity, electric force, magnetic, friction, we talk a lot about, and then air resistance. Inertia. Inertia. It's when an object at rest stays at rest until some force acts upon it. So if a book is sitting on a table, it's going to stay sitting on a table until some force acts upon it. That's showing inertia. An object in motion will remain in motion until acted upon by an unbalanced force. So something that isn't in a constant motion and in direction is just a constant motion. That's showing inertia. The only time it's going to slow down or speed up or anything like that is going to be if an unbalanced force is applied to it, whether it's friction or air resistance, something like that. When all forces acting on an object are equal, we say that they're balanced. That's showing inertia. Okay, when all forces acting on an object are equal, that is when they're balanced. What are balanced forces? When all the forces acting on an object are equal, the net force is zero. Remember what we talked about with the paycheck. Okay, you can get a job, you can earn so much per hour, but that's not how much you get in the check when you finally get payday. You get what's called net pay. It's how much you earned plus all these other things taken out of it. It takes into account all of the things that you earned and things taken out. All of that into account. That's the net. Okay, so that's kind of like what this is. But the net force is zero. That means everything is balancing out. That means it's balanced. Balanced forces do not cause a change in motion. So if something is still, it's going to stay still. Something in constant motion is going to stay in motion. That's balanced. Balanced forces can change the physical properties of an object without changing its motion. Picture this: a car, a beat up old car in a compactor. There's force coming from both sides. The car's not moving, but the force applying on both sides is squishing the car. Is it changing the shape? Yeah. Okay, but the car's not moving. It's not changing its position. It's in the same spot. So that's considered balanced force, and that's a changing in shape. How can balanced forces affect objects? How can they affect objects? They can cause the shape of an object to change without changing its motion. Same thing what I just talked about with the car and the compactor. Okay, the car's not moving anywhere, but the forces are causing it to change its shape. How can balanced forces affect objects? It can cause an object at rest to stay at rest. So if it's still, it's going to stay still. Or an object to stay in motion if it's already in a constant motion, showing inertia. It can cause an object moving at a constant speed to stay at a constant speed. Okay, now unbalanced forces. When all of the forces acting on an object are not equal, So one of the pairs has more magnitude than the other. That's unbalanced. It's going to change the position of the object. The force can be in the same direction. Okay, so if I was going to push the table, push it out of the way, and someone else came and helped me, we push it out of the way together. There's two different forces on that one object being pushed. So that's what that means. Or an opposite direction. Okay, I could be pushing the table. Somebody could be pushing the table from the other way, and we're pushing it towards each other. But I don't have a whole lot of muscles, so whoever's pushing it against me might, and I'll be going backwards. That's unbalanced. Okay, so that's an opposite direction. Unbalanced forces cause a change in motion. So if me and somebody else were pushing on that table, two different forces, the table's going to move. Okay, without a doubt. If someone is pushing the table up against me and they're stronger than me, that table's going to move backwards. Okay. How can unbalanced forces affect objects? Acceleration is caused by an unbalanced force. So when there's unbalanced forces on an object, that means the object is going to accelerate. Accelerate does not mean to go faster. Okay, we hear that a lot in like TV shows, and they're driving and I'm accelerating. That does mean to speed up. That's one of the things, but that's not all. It also means to slow down. If you slow down, you're accelerating. If you speed up, you're accelerating. If you come to a stop, you're moving and then you come to a stop, you're accelerating. If you're at a stop and then you start up again, you're accelerating. All that's accelerating, and I'm not done. A change in direction. So if I'm walking this way and then I go back that way, I just accelerated. I didn't walk any faster or slower, I just changed direction. Or I'm walking down the hallway and I turn the corner, I'm accelerating. I changed direction. And then the change in shape, well, let's say these tables were paper and the stronger person was going against me, it's going to crumble up a little bit on their side and move at the same time. Net force. We've been talking about net force. It's the total of all forces acting on an object. So forces can be either in the same direction, and if they are, we add them together. So me and the other person pushing that table, we're going to add our forces together, and that's going to be the net force. Okay. Forces in the opposite direction, we subtract. So that strong person pushing the table in the opposite direction is me, and the table's moving, I'm going backwards. We're going to subtract those forces and show the difference. That will be the net force. So let's practice. Okay, so we have a child playing with a jack-in-the-box. The lid is pushed down, on a spring with 10 newtons of force. So we'll say someone's pushing the lid down. 10 newtons of force. While the spring on the inside is pushing up when it gets released at 30 newtons of force. What is the net force applied by the spring? Okay, so the spring, someone's pushing it down, that's 10 newtons. Okay, when it opens up, the spring pushes back on the lid at 30 newtons. I want you to take notice of these arrows. Usually when you see a longer arrow, that means more magnitude. When you see a shorter arrow, that's less magnitude. So we have 30 newtons pushing upwards. Okay, 30 is a higher number than 10, so there's more magnitude going up, and there's less magnitude coming down. So what we saw in the slide before, if the forces are in opposite directions, so here it's one up, one down, we're going to subtract to get our net force. So 30 minus 10, 30 newtons going up versus 10 newtons going down, we subtract that, and that's going to be 20 newtons, but that's not the whole answer. You do need to say in what direction is movement, because these are unbalanced forces, so the net is not going to be zero. If the net's not zero, you need to say what direction the object is moving. So in this case, the lid is moving up. So 20 newtons up. Let's do one more. A tug of war game. Okay, so we have, and notice the arrows. Okay, this one's a little bit thicker. Okay, 30 newtons to the left and 50 newtons to the right. Okay, two competitors are playing tug of war. What is the net force? Which direction will the rope move? So we're in opposite directions, so we're going to subtract. We're going to subtract 30 from 50. Okay, and that's only part of the answer. 30 from 50. So 50 is going to the right, 30 is going to the left. Okay, so that's 20 newtons. But which way is that rope moving, to the right or to the left? Well, whichever way that there's more force. So it's going to be 20 newtons to the right. Okay, and we'll do more practice problems on Thursday. Today you're taking notes, and then you're going to go back into Schoology and then complete a short assessment. Okay, thanks for taking notes, guys.